You ever use an AI coding assistant and it just feels like magic? Like it actually gets your project? But then you try another AI tool and it feels more like a slightly smarter text editor. What's the deal? Well, it turns out the magic isn't just about the AI model itself. In this explainer, we're going to pull back the curtain and see what's really going on under the hood.
So this is the central puzzle we're here to solve. You could be using the exact same foundational large language model, an LLM, in a basic chatbot and in a specialized coding tool, but the experience is just night and day. One gives you pretty generic advice, while the other feels like it's actively working with you. So what's the secret sauce?
And this comparison really nails the difference. On one side, you've got a raw LLM. It's basically a conversationalist. You give it text, it gives you text back. Simple. But a coding agent? That's a true partner. It has hands, it has eyes, it can dig into your files, it can run commands, and it can actually remember what you were talking about an hour ago. It's an active participant, not just a passive chatbot.
So here's how we're going to break it all down. First, we'll get to know the key players, the LLM, the agent, and this thing called a harness. Then we're going to do a deep dive into that harness and look at its 6 most critical parts. And finally, we'll tie it all together to see why this whole system is what really creates that magical experience.
Okay, let's jump right in. To really get what's going on, we got to make sure we're all speaking the same language. We need to get these 3 fundamental concepts straight.
So at the very heart of all of this, you have the large language model, the LLM. This is the raw brain power, the part that's just really good at predicting the next word in a sentence. The best way to think of it is as the engine. It's got a ton of horsepower, but on its own, it's just an engine sitting on a block. Now you can take that standard engine and you can supercharge it. That's when you get a reasoning model. It's still an LLM in its core, but it's been taught to think things through step by step and double-check its own work. It's a way more powerful, beefed-up engine, but it also burns more fuel. It takes more compute to get that extra performance.
So you've got this awesome engine. But here's the thing, right? You can't actually drive an engine down the road. You need to build a whole vehicle around it. And that vehicle, that's the agent. It's the control system that gives the engine wheels, a steering wheel, and a GPS. In other words, it provides tools to interact with the world, a memory to keep track of where it's been, and a goal to work towards.
And here's how it all stacks up. You start with that core engine, the standard LLM. You can upgrade it to a more powerful reasoning model. But to get a truly high-performance system, you have to put that engine inside the full vehicle, an agent that's equipped with this special harness. And that harness? That's what we're really here to talk about.
We've thrown this word around a few times now, the harness. Well, this is it. This is the answer to our original question. This is the real secret sauce that makes the best AI tools feel so incredibly smart.
Think of the harness as the entire chassis, the dashboard, the steering, and all the wiring in our AI vehicle. It's this super sophisticated software layer that manages everything the model needs to actually get stuff done in the real world, like the context of your project, the tools it can use, how it remembers things, and the overall flow of the task. It's what shapes the entire user experience.
So the really important thing to understand is what this harness is actually made of. It's not just one thing, it's a bunch of smart systems all working together. So let's pop the hood and break down the 6 key components that make this high-performance vehicle run so smoothly.
We're going to look at how the agent figures out where it is with live repo context, how it communicates super efficiently with prompt shaping, how it actually gets its hands dirty with tool access, how it stays focused by minimizing context bloat, remembers what it's doing with structured memory, and even how it multitasks using delegation.
First up, context. Think about it. If you ask a human developer to go fix the tests, they don't start from a blank slate. They instinctively check the project layout, the Git branch they're on, maybe the README file. Well, the harness gives the AI that exact same awareness. Before it writes a single line of code, it gathers all these stable facts so it has a map of the territory. Next up, let's talk about efficiency. It would be a total waste to have to re-explain the entire project and all the available tools to the model every single time you send a message. So a smart harness is designed to separate the stable stuff, like tool descriptions or that repo context, from the things that change, like your latest request. It then caches and reuses that stable part of the prompt, saving a ton of time and compute.
Okay, so how does the agent actually do anything? This is how it gets its hands. The model doesn't just start typing code randomly, it suggests a very specific action, like list files. The harness then acts like a careful supervisor. It checks if that's a valid tool, if the arguments are okay, and it might even ask you for permission first. Only then does it safely run the command and feed the result back to the model. It's this safe, reliable loop.
Now this brings us to a huge problem: information overload. Real projects have long files, super verbose log outputs, and a huge conversation history. If you just dumped all that raw info on the model, it would totally drown. So a good harness acts like a great editor. It clips long outputs, gets rid of duplicate information, and summarizes older parts of the conversation, making sure the model only sees what's most important right now.
To manage all this information, the agent needs a memory. But it's not just one big junk drawer of text. The harness is smart about it, using at least 2 different layers. You've got the full transcript, which is kind of like a permanent, super detailed logbook of the entire session. And then you have the working memory, which is more like a sticky note on your monitor, just a small, condensed summary of what's important for the immediate task.
And last but not least, a really advanced move: delegation. When you're tackling a complex problem, you often run into these little side quests. Instead of getting totally sidetracked, a really sophisticated agent can actually spawn a sub-agent, like a little helper, to go figure out a specific piece of the puzzle on its own. This lets the main agent stay focused on the big picture, which is just a much more effective way to work.
Okay, so we've looked at all the nuts and bolts. Let's zoom back out now and really hammer home why this entire system, this whole approach, matters so much.
And this quote from Sebastian Raschke in the source material just says it all perfectly. A lot of apparent model quality is really context quality. The magic isn't just about having the biggest, most powerful engine. It's really about the finely tuned vehicle you build around that engine. A great harness is what takes a good model and makes it feel like an absolutely exceptional partner. It flawlessly handles all that tedious, mentally draining work that even we humans find difficult, like managing context, juggling a million pieces of information, and using tools with precision. And that frees up the core AI to do what it's best at: reasoning and coming up with brilliant solutions.
And that really brings us to the big takeaway. We've been focused on coding today, but this core idea of building a sophisticated harness around a powerful AI engine is universal. You could apply it to scientific research, law, medicine, anything complex. So I'll leave you with this question to chew on. Beyond coding, where do you think the next great AI harness is going to completely change the game?